Hi everyone, welcome to another episode of Pen and Paper Programming. As you probably noticed that I am not using an actual paper. I've decided to use a digital device to see how I like recording questions, and I will give it a try a few times and I hope I like it and it's much easier for me to record more questions. Let me know what you think. If you like it, give it a thumbs up. If you don't like it, leave some comments. I will see what I can do. But anyways, this is a change. I hope you don't mind. This particular question is asking us to write a program which tests if two rectangles have non-empty intersection. If the intersection is non-empty, return the rectangle formed by their intersection. So here are some examples. If you're looking at B and C here, we know that there's an intersection, and what we need to return here is this rectangle right here. In the case of D and F, we would need to return this rectangle right here. In the case of A and B, the question is specifically asking us to consider this an overlap, but in this case we would get the actual intersection point, but the width and the height of the rectangle would be 0. This is what the question is asking. Well, let's get started. As the solution indicates, there are many qualitatively different ways in which rectangles can intersect. They have partial overlap like D and F. One contains the other like F and G. Basically, the case analysis is quite difficult. A better approach is to focus on conditions under which it can be guaranteed that the rectangles do not intersect. For example, the rectangle with leftmost lower point 1, 2, width 3, height 4, which would give us this rectangle 1 to 4 on x-axis, and then 2 to 6 because height is 4 on the y-axis. So we have our first rectangle here, right? The solution is indicating that this rectangle cannot possibly intersect with a rectangle whose lowermost value is 5 and 3, x is 5 and y is 3, where the width is 2, we come up to 7 right here. Height is 4, 1, 2, 3, 4, we go up there. Okay, so this rectangle here, solution is saying that these two cannot intersect because x values of the first rectangle range from 1 to 1 plus 3, right? So that is 1 plus 3, which is 4. It comes up here. And the case of the other one, where we start with 5 and the width is 2, 5 plus 2, it ranges from 5 to 7 inclusively. So we have 5 to 7 and 1 to 4. There is no overlap at all on the x-axis, right? Similarly, if the y values of the first rectangle do not intersect with the y values of the second rectangle, these two rectangles cannot intersect. We should write code that would determine if they do not intersect. If they do not intersect, we're good. If they do intersect, then we would actually need to calculate the intersection point. Let's take a look at the code and actually walk through these examples with the code. I think that's going to make a lot more sense. Let's walk through the code with a few examples. The first example is not going to have an intersection, so we will return a rectangle that is empty. And then we will take a look at another example where there's an intersection, and we will actually return that intersection area. Let's write down a few values about these rectangles. We have R1. For R1, we have X, we have Y, we have width and the height. And R2, again, we have X, Y, width and height. I believe the first example the book gave was X was, right, I'm looking at it right now actually. X is 1, Y is 2, width is 3, and height is 4, right? 1, 2, 3, 4, yes. And R2 is here, X is 5, and Y is 3, and we have 1, 2, 3, 4. Width is 2, and height is 4. So I'm walking through this code where at the very top we have this rectangle object. I think it's pretty straightforward, basically a Python object, and we have intersect rectangle R1, R2, right? And we come to isIntersect method. Here we're looking at R1x less than equal to R2x plus R2 width. Basically, R1x is 1, and R2x plus R2 width is, here we have x plus width, that would be 8. I'm sorry, x 5 plus 2 right here, right? This is the x value plus 2, right? It is less than or equal to 5 plus 2. Is that true? That's true. And we have the other condition, which is r1x plus r1 width greater than or equal to r2x. r1x is 1, plus r1 width, which is 3, is that greater than or equal to r2x, which is 5. Well, that's not true because 4 is not greater than or equal to 5. There's no overlap. The x's could not overlap. As a result, if not is intersect r1, r2, it's going to return a rectangle here, which is 0, 0, minus 1, minus 1. Our first example here, there's no intersection. Now, let's go through another example where there is actually two rectangles and they have an intersection. I put two rectangles, r1 and r2. R1 is x is 1, y is 2, width 3, and height is 4. This red rectangle right here. And then R2 is starting at x2, y3, and then width and height, which is 3 and 4. Our program needs to return intersection, which I shaded in blue. Does that make sense? Okay, so let's walk through the code. We're going to call is intersected r1 and r2, which is going to do r1x, which is 1, is it less than or equal to r2x, which is 2 plus r2 width. That's true because 5 is greater than or equal to 1. And it's going to say and r1x, which is 1, plus width, which is 3, greater than or equal to r2x, which is 2, right? Which is true as well. Okay, so this one, x coordinates satisfy. And then we have another end, then we say r1y is less than or equal to r1y is 2, is less than or equal to r2y plus r2 height. R2y is 3, r2 height is 4, 7, which is, it's 4, which is 3 plus 4 is 7. 2 is less than or equal to 3 plus 4. Yay, this satisfies as well. And then lastly, we do r1y plus r1 height, which is r1y is 2 plus 4. That is greater than or equal to r2y, which is 3. This satisfies as well. This condition where it says if not is intersect is actually false. Therefore, we're not going to return an empty rectangle. We're going to go to the next line, which is returning a rectangle. Let's walk through that code with our example next. What we want to return at the end is basically x, y, width, and height. Right? That's the rectangle object we're going to return. So what we really want to return is this intersected area right here, which I shaded blue. And we're walking through the code where it basically looks at it as max of, we can return max of r1x and r2x, right? 1 and 2, which is going to return 2. That's our x coordinate, which is right here. Makes sense, right? We don't want to pick this x coordinate, which is 1. We want to pick the max right there. And then for y, we're going to return max of 2, and r2y is 3, which is 3. So our x coordinate is going to be 2 and 3, not 1 and 2, right? Because that's intersected area. Now we need to return width and height. For width, we need to take the min of r1x plus r1 width and r2x and r2 width. In this case, r1x is 1 plus 3, 4, and r2x is 2 plus 3, 5. We need to take min. The min of that would be 4, right? For our width, 4 minus the max of r1x and r2x. In this case, max is 2. That would be 2. Our width is 2, right? As you can see it right here, this is the area we just calculated, which is 2. And now we need to calculate the height, which is this area. And for that, we are taking r1y plus r2 height, which is r1y is 2 plus height, that is 6. We need to take min of 6, and r2y plus r2 height, which is 3 plus 4, 7, minus max of 2 and 3. In this case, that would be 3. So that would be 6 minus 3, and our height is 3. We are going to be returning a rectangle that is 2, 3, 2 width, and height is 3, right? So 2 and 3 right here, right? And the width is 2 and height is 3. 1, 2, 3. And that's going to return us this intersection right here. I hope this made sense. If you find it useful, please subscribe to the channel and hit the like button. And if you have any questions, just leave it in the comment section. Thank you for watching.